Hello there, programmers, and welcome to another installment in our Pygame tutorial series. What we're going to do today is we're going to jump in and create a clone of the game Flappy Bird. Now, if you've played Flappy Bird, you know that it's a pretty simple game. The concept is you tap the screen or hit a button and your bird flaps its wings and flies higher on the screen. If you stop tapping, the bird stops flapping and falls lower on the screen. Now what we're going to do tonight is we're going to build that game out, but we're going to change out a few things. We're going to use some different art assets. And speaking of art assets, I like to use Kenny.nl. Has a ton of free assets. These are 100% free for you to use in any game that you build from now on. And I'll include the link in the description down below for Tappy Plane, which is their plane-themed version of the Flappy Bird game. Okay, so you can click on here and see this is the kind of assets that get included in here. We're only going to be using a handful of these for this tutorial, but you can definitely use these to expand the game, make it a lot more complicated, unlock a lot of different features, and basically take what we build here and improve upon it and build your own thing using these assets. So if you want to go ahead, if you haven't yet, go to this URL, download the link here, and go ahead and set up your project directory with a virtual environment. Okay? All right, hopefully you've done that at this point. What I'm going to do is I'm going to grab a few assets out of here. I already have them ready to go. So what I'm going to do is actually just copy them and paste them into this, into here, and I'll show you which assets I've actually brought in. So we're going to need a background. We're going to need grass, the ground here with grass on it. You can use whichever the grounds you want. There's a lot of them in there. I'm using the blue plane. Use all three of the plane images you need because we're going to work on animating sprites as part of today's tutorial. And then we need two rock structures and the game over text. And that's it. That's all the art assets that we're going to be using for this game. So go ahead and grab those out of the directory you just downloaded. Create a folder inside of your project called assets and add those into there. Okay. Next, what we're going to do is we're going to do a pip install inside of our directory, and we're going to install Pygame. So once our virtual environment has that, you'll grab the latest version, which for me is 2.0.1. And so once that's installed, we can go ahead and start building our game. Okay. We're going to create a main file here. So let's go ahead and create main.py and jump straight into the programming. So what I'm going to do is I'm going to set just the basic main function here equals underscore main. And you know what? Let's grow this, make this a lot bigger here so it's easier to read. All right, there we go. Hopefully that's a lot easier to read than that small little text. And all I'm going to do right now is I'm going to say wall true and pass. Okay. So what we're doing is I'm setting up the main loop of the application. Okay, so this is just going to run forever. We're going to instantiate our game inside of here, and then we're going to actually just run it forever until we get an exit event from the game itself. Now, this is a little bit different. If you followed my previous Pygame tutorials, these things are going to work a little bit differently than they did in the previous tutorials. In those tutorials, we created one file and we put everything for our game inside of it, which is fine. It's a good way to build small games, but we're going to start working towards building more and more complicated games in this series, and this is going to be the first of those. So what we're going to do instead of just building out things in here is we're going to create a new folder or directory under here, and we're going to call this game. Okay, this is the game directory, and inside the game directory we're going to create a new under init.py. Okay, so we're going to create this game module, and we're going to create the init file. This is going to be the thing that actually holds all of our game logic. Okay, so what we're going to do is inside of this init file is where we're going to set up our game object. And to do that, we're going to import Pygame. And let's go ahead and import sys as well, because we're going to need that later. And then we're going to set up a class, and we're going to call this class game. This is going to be the main game object. This is the thing we instantiate in our main file. And then inside of it, we need to set up a couple of things. First, we're going to set up the init, and we're going to, inside of init, call pygame.init. That's the first thing we're going to do. Then we're going to set up another method here. We're going to set up handle events, and we're going to pass for now. All of these we're just going to set up and then pass on so that we can come back and actually fill them in later as we build out the content of our game. Then we're going to do a draw, and we're going to pass on it as well. And finally, update. Okay, so we'll go ahead and pass and save this file. Okay, so what we've done is we've set up a shell class here. We've call it game. We set up Pygame init, and then we have three methods that we're going to call: handle events, draw, and update. All right, so let's go back to our main file here, and inside of all of this, the very first thing we're going to do is we're going to call an import statement at the top. We're going to from game import game. Okay, and then at the top of our main, we're going to say game equals a new game object. And then inside of our loop, there are only three things we need to do here forever. This is all that we need to do in this file. First, we're going to say game.handle events, game.draw, and then game.update. Okay, we'll call things in this order. And what this will allow us to do is we can now finish with this file and go ahead and close it. We don't need anything else in here. All that this is going to do is whenever we run, so if we go ahead and hit run right now, you'll see nothing actually happens. It's just going to spin up everything. There's no window, nothing's being stood up. It's just an empty Pygame instance, and you can see Pygame 2.0.1 with SDL 2.0.14 and Python 3.9.0. Okay, so we know that Pygame is installed, everything's there, but we're not actually showing anything yet. Okay, so that's it. That's all we need here. Let's go ahead and close main.py. We're not going to have to work in that file anymore. Now we're going to be working in the init of our game and then everything underneath it. All right. So what's the first thing we want to set up? Let's actually get something showing up on the screen so that we can verify everything's working as we expect it to. Okay, so let's do self.screen. We're going to create a screen object. This is the thing we actually draw on, and we're going to call this display, pygame.display, if I spell that right, display, and then we're going to set the display mode. For this, we're going to need to pass in a width and a height here, okay? That's the size of the window that we want to show. This is our our next file that we're going to add. We're going to go over here to game, and we're going to add a new Python file, and we're going to call this constants.py. Okay, and we're going to go ahead and just define everything that we're going to need inside of this file for now. So we're going to call this class constants, and inside of here we're going to do screen width th equals, and we're going to do this 800 by 480. Why are we doing 800 by 480? I'm glad you ask. So let's go ahead and set this up here, 800 by 480. Make sure this is nice and big for everyone to see. And there we go. Okay. So we are doing 800 by 480, and the reason we're doing that is because if you come back here to the directory with all of our downloads in it, this is our background image that we got from kenny.nl, and this background image is 800 by 480. So we're going to create the game window the same size as the background image that we're using, just to make things easier moving on. Okay, we're not going to change the size of any of these assets to make things simpler. All right, so we've set up our screen, and now what we need to do is at the top here, we're going to say from game.constants, import constants. So these are the constants we're going to use. And then inside of here, all we have to do to use this is constants dot screen width by constants dot screen height. Okay, that's it. So now we've set up our actual screen, and then we'll go ahead and set up a clock. So this is going to be the thing that we keep track of our cycles on, our clock cycles. And then from here, let's go ahead and add our background. Yep, let's go ahead and do that. So we're going to say self.bg surface. So this is going to be our background surface. Now there's a difference here. The display is the actual window itself, and a surface are the things we draw on. Okay, so we're gonna create a background surface, and to do that, we're just going to load in a Pygame image, and we'll do a load, and then we pass in the actual image we want to load in relative to the root of the project. So in this case, it's going to be assets / background.png. And one thing I like to do here is I like to call convert. What this does is it optimizes this image inside of Pygame to make it run a little bit more efficiently. So I like to do that on all the assets that I bring in like this. Okay, what else should we set up in here to, before we run? Let's set up some events, okay? So we'll do keys, pygame.key.getPressed. So what we're doing is we're grabbing all of the keys that have been pressed, and then I'm going to go ahead and set up the key that we're going to use to control. So as I said, this is like Flappy Bird, where we hit a key to make the bird flap its wings and rise up. And so what I'm going to use is just one keys, and we'll say it's pygame.k space. I'm going to use the space bar. Okay, that's all I'm doing here. I'm not going to do anything for now. We're just going to pass this, but I want to go ahead and get that set up so that we can easily come in later and use it. The other thing I want to do is set up the event loop. So each event that comes in, we want to read and see if we can see pygame.event.get, see if there's any events in that loop. If the event.type equals pygame.quit, we're going to call pygame.quit and sys.exit. Okay, so the next steps we need to do is we need to set up our draw and our updates. Okay, the way we're going to do this is we're going to call inside of our draw self.screen.blit. Blit is a fancy graphics term for draw something to the screen. And we're going to say self.bg surface. And we're going to pass this in at the 0, 0 origin. Now, in Pygame, origin means top left. 0, 0 is the top left corner, and we count in the x-axis up by going to the right, and in the y-axis up by going down. It's the opposite of what you learned in algebra class. Okay, and that's all we need for the draw for now. We'll be drawing other stuff later, but for now that's it. And then we need to call pygame.display.update. Here, let's grow this a little bit bigger. I forget that it doesn't automatically grow everything big. So inside of our update function, we're going to call pygame.display.update and self.clock.tick, and we're going to tick 120. Okay. So I think that's it. That's all we need for right now. Let's go ahead and hit run and see what we get. Look at that. Now we've got a background image showing up on the screen. Move the screen around, everything's drawing as it's supposed to. And As I said, we already set everything up in the main.py, so it's just running through the loop, redrawing this to the screen every time it updates. Okay? Pretty straightforward, pretty simple. All right, so let's now actually start making this into a game. The very first thing we're going to do is we're going to add a ground. We're going to add a floor for us to intercept when we're flying with our plane. Okay? To do that, I'm going to go ahead and set up a new file over here. So inside of my game folder, I'm going to create a new Python file, and let's call this floor.py since it's the floor. And you can also call it ground.py. It doesn't matter what you call it. But inside of this, we're going to import Pygame, and then from game.constants, import constants. We're going to use these constants to know how wide the window is, so that as the ground moves underneath us, we'll know when to reset as we animate our actual ground moving. Okay? All right, so let's go ahead and we're going to set up two classes here. I'm going to set up a class called floor. This is going to be the actual game object that represents all of the core logic around drawing multiple grounds and keeping track of where they are as they move, resetting them, all of that, okay? So that's going to be this class. And then I'm going to set up a second class inside of here, and we're going to call this the actual ground. Now, what this is going to be is this is going to extend from pygame.sprite.sprite. Okay. What this means is that this class is going to be the one that actually holds the art asset, the actual sprite asset. Okay. We're going to load in the image, we're going to update its position, we're going to create a mask for collisions. All of that is going to be contained inside of the sprite class. So our floor is a game object container, and the ground is the actual art that gets drawn on the screen and all the physical properties related to it. Hopefully that makes a little bit of sense. It'll make more sense as we dig into this a little bit here. Okay. So the first thing we're going to set up is the ground. Okay, let's go ahead and create two functions inside of here. We're going to create an init, and we're going to give this an offset. You'll see why in a second. And we're going to set the default to 0. Okay, and then the very first thing we want to do is call super.dunder_init. And what this is going to do is call sprites initialization, which sets up all the drawing aspects of this. Okay. Now, we'll save our offset that we pass in as inside of the self, and then here's where things are going to get a little bit weird. I'm going to use a hard-coded number here, and I'm going to show you where that number comes from. We have the ground that we're using is this one here, ground.grass, and it has a size of 808 by 71. Okay, so all the numbers I'm using in here are derived off of this. It's considered pretty bad practice to hard code these things in case you change your art assets and things like that, but to make this much simpler and shorter, we're going to hard code some stuff for now. Okay. So let's go ahead and inside of here, let's zoom in a little bit so this is easier to see. We're going to set self.x_pos. This is a built-in property of sprite. This is our x position of the sprite itself, okay? And we're going to set it to 404 plus self.offset. Now the reason we're doing that is because this art asset is loaded in its center point. Like it's centered inside of itself when you load it into the sprite, okay? So we need to move it over 404 pixels so that its left edge lines up with the left edge of the screen, okay? And then we're going to set the self.y position, and we're going to set that to constants.screen height. So we're moving it all the way down to the bottom, and then we're subtracting 35, half the height of the actual image itself, okay? A little less than half, but Yes. So we're moving it all the way down, and because it'll be at the halfway point, it'll be halfway off the screen, we're going to move it back up, budge it back up just a tiny bit so that it comes back onto the screen a little more. Okay? Then I'm going to set up a function, property here called delta, and I'm going to set that to 1. We could probably move this off into our constants file if we want to later, but for now we're just going to hard code this into the ground because it's going to be pretty contained to the ground object itself. What delta is how much will this object move every time the screen updates. Okay? And then we're going to do self.image, and we're going to set that. This is where we're going to load in our actual image. Image.load. I'm going to bring in assets/groundgrass.png. Okay? And we're going to do, instead of a convert, we're going to do a convert alpha here. What this does is this optimizes the surface, but it also takes into effect that some of the actual image is has alpha transparency enabled on it. Okay, which is important for this ground because, as you can see, if I load this image here, you can see it kind of zigzags, and if I turn on the whole image and show the chessboard, you can see there's more to this image than we can actually see. Okay, so if I didn't turn on the convert alpha, all of this up here would be black. So we don't want that. We want the alpha to be see-through. Okay, so that's what we're doing here. And then we're going to set up a mask. Now the reason for this is we're going to do collisions between our objects later, and traditionally if the object is exactly at the outer bounds of its rectangle, if its rectangle matches its size, we don't have to do this, but because this object actually cuts into the outer bounds of the actual loaded in image, we only want to intersect where there's colored pixels. That's what a mask does. So the way we grab the mask is we can say pygame.mask.fromSurface. And what this does is we take the image that gets loaded in, because it's alpha converted, we can just grab what pixels are actually colored in and create a collision mask based off of that. Okay? And then once we do that, we have to set up the rectangle of the sprite based off of the image that we loaded in. Okay? We have to set them so that they match. They don't by default match when we load in the image. And then we're going to move the rectangle. And we're going to move it to where we just set our self.x position and self.y position. Okay? So that's what we're going to do. We're going to move everything where it needs to go. We're going to set the rectangle. By setting this rectangle of the actual sprite, we're able to move it wherever it belongs. Okay? Next, we're going to create an update function. Okay? This is overriding the default update function that is called inside of the sprite. One of the benefits we get by using a sprite is that it automatically calls an update function and a draw function for us. So if we overwrite update, we can make this sprite do things whenever the update function is actually called. And that's what we're going to do here. We're going to set self.xPosition minus equals self.delta. So we're going to shift the x position to the left delta units, 1 unit in this case. If self.x position is less than, here's some of this funny math again, negative 404 plus self.offset. Now, what this is checking is the image completely off the screen? If it is, what we want to do is we want to set self.x position back to the 404 plus self.offset. Okay? Now, what else do we want to do? Self.rect.center. We're going to set that to self.x position and self.y position. So we're going to shift Now we're actually going to move it. This is the actual move. We're calculating the deltas, we're calculating the changes, and then we're updating the actual position of the object based off of this. Okay. Hopefully this is not too crazy. We're doing sprites now instead of in our previous tutorials where we've done just drawing straight objects to the screen. Here we're actually drawing an image and we're going to move it. We're going to update it. Now to create the actual floor. Okay. Our floor is going to consist of two ground objects side by side, and they're going to move together in lockstep. And then as the left ground object moves off the edge of the screen, we're going to shift everything back so that it is back in the original position and start the movement again. This way it looks like it's continuously moving and scrolling infinitely, while in fact all we're using are two ground objects. You'll see what this looks like in just a second. You'll see all we're doing is setting up ground 1. We're going to set this equal to ground. And then we're going to set up... Oh, you know what? This isn't going to work if we don't actually call this inside of an init function. Sorry. Def init. And then we're going to pass into this init. We're going to pass something in here. We're going to pass in what's called a sprite group. This is the thing that's going to do all the magic for us of calling the updates and keeping track of all of these, the actual sprite stuff for us. Okay. So we're going to, there we go. Now we're getting lit up self dot ground 2. And this is going to equal another ground. This one, we're actually going to pass an offset. And the offset is 808 pixels, because that's how wide they are. We want them to line up together exactly every 808 pixels. Okay. Then we need a little bit more here to make this all work. We're going to say self.floor sprites is equal to pygame.sprite.group. So we're going to set up our own group internally. So as I said, this is the game object that's going to manage the ground by itself. Okay, so it's going to keep track of all the sprites that are part of itself. Self.floor sprites.add self.ground 1 and self.ground 2. Now what we can do is as you can see here, this function allows us to add a star sprites. So multiple sprites. We can give it a list of sprites. Okay, and that's what we're doing here. We're adding 2 sprites into this group internally. Then what we're going to do is we're going to do the same thing for sprite group.add self.ground1 and self.ground2. We're adding the same 2 ground objects into 2 different sprite groups. The reason being, this main sprite group is going to be the one that holds all of our sprites, and it's going to be the one responsible for making sure they all move, they all update, they all draw. This sprite group internally is going to be used for our next function, which is going to be important later on when we actually have a player object. What we're going to do is we're going to check player did collide. Okay? And we're going to pass in self, and we're going to pass in a player game object. Okay? Now, we haven't defined that player yet, but when we do, we'll be able to call this function with that object and see, has the player intersected with the ground? The way we do that is we say if pygame.sprite collide. Okay, oops. I hit keys. There we go. Sprite collide. Okay, and then we pass in 2 things. One, we call in the sprite we're checking for collision, and then the second argument is a sprite group of all the sprites that we want to check for collision with. That's why we set up that sprite group above. So we can say player, and then we can say self.floor sprites. Okay. Then we're going to pass in a couple of things. Do we want to kill if a collision happens? And the answer is no, we don't. what kill does is it removes that sprite from a group, okay? And it causes the kill, all the kill actions to actually happen. We don't want to do that. We want to control everything ourselves. And then the final thing we're going to do is we're going to pass in a collided object, okay? So we're going to say COLL collided equals, and then we're going to pass in pygame.sprite.collide mask, okay? And get rid of the function. We're passing in the raw function itself here as the argument. What this does is this says we want our collisions to be based off of the mask, not the actual rectangle boxes of the sprites. This is why we set up our mask down here. If you look here, we set up this mask. Now we're saying collide based off of that mask that we set up. We're giving it the function to be able to call to see, did these masks collide? Then if it's true, we're going to return true. Otherwise, we return false. Okay? Oops, capital F. Too much time in other languages. Okay. F-A-L-S-E. There we go. All right. If I could spell, this would be so much faster. All right. So now we've set up our entire ground object. Now we need to actually load it in to our initialization. The way we're going to do that is up here after constants. We're going to say from game.floor import floor. That's all we need. We need the floor object. Okay. Then we're going to come down here after we set up our background surface inside of our initialization. We're going to set up self.all sprites. This is going to be our main sprite group. This is going to be what actually gets called to draw everything. And we're going to set it up using the sprite dot group. Okay. And then we're going to set up self.floor. It's going to equal the new floor object. And we're going to pass in that sprite group we just defined. All right, after we set up this floor, then we can come down here into, we don't need to handle anything for the events. Okay, we'll actually do that in just a little bit when we add our player. So after our floor, we need to come down to draw, and we need to call self.allsprites dot draw, and we need to pass in the screen object. Okay, so this is where we actually draw it, and then down here, before we call Pygame display update, we're also going to call self.allsprites dot update. Okay, so this is where we actually call the update on each of the sprites that's inside of here. This is where we call the draw and blit those objects to the screen, just like the background surface above. So let's run it. Let's see what it looks like. If we run this, there we go. Now we have a floor that moves across the bottom and will continue to scroll forever. Okay? So, what can we do next? Let's add a player. Let's make this actually playable as a game. We'll worry about adding obstacles later. For now, let's get a player set up. Okay? So over here, we're going to go to game. We're going to create a new object. We're going to call this plane.py, because instead of a bird, we're doing airplanes. I like airplanes more than birds anyway. So we'll import at the top Pygame and import game.constants. We're going to, oh, nope, from game.constants, import constants. There we go. Helps if you do things in the right order. There we go. All right. And then we need a class. Call this plane. Pygame.sprite.sprite. So we don't need any fancy container object for this. We're just going to be working with the raw sprite for our plane. Okay. We are going to do things a little bit differently inside of here, because instead of just being a single sprite, this is actually going to be an animated sprite. So this will be a little bit fun here. So I'm going to create our initialization function. and we're going to call super.init, and then we're going to set up self.frames. So this is going to be all of the frames of our animation. Okay. Okay, yeah, so let's go ahead and create our frames, and we're going to load in 3 images here. So we're going to create an array. I'm going to say pygame.image.load, and we're going to load in an asset. Assets slash plain blue.1.png. Whatever color plane you ended up picking, go ahead and use that here. And then we'll call convert alpha on this. I'm going to copy this line and paste it 2 times. And then I'm going to change plain blue 1 to plain blue 2, and then plain blue 2 to plain blue 3. Okay? Then we'll set up self.frame equals 0. This is what frame index we're actually on. And we have to count because we don't want this to change every time the update function is called. If we did that, it would be blurry and messy and look gross. So we want to actually count a few update cycles in between each update so that it looks more like a natural animation. Okay. So then we're going to do self.image equals self.frames. And we're going to call self.frame here. Okay, so what we're doing is we're setting the image to the first image that gets loaded in the frames object. All right. Then we can set up our mask for collisions. Pygame.mask from surface, and we'll call it from self.image. Okay. Then we need to grab the rectangle based off of that image. Okay. And set the Y position. And we're going to set the Y position to constants.screen_height divided by 2. What we're doing here is we are setting this to halfway up the screen. Okay. We don't need to set an X position. Since this is a Flappy Bird game, we always stay at the same X position on the screen forever. We only move up and down. We don't move left and right. So we're going to set our rectangle center, and we're going to set this to, we're going to move over 75 pixels from the left, and then self.y position. You can experiment with this, move it around a little bit as you want to. You can also move that value into constants if you want to. But again, I like to put things into constants that are going to be global constants, not local constants, okay? And then the last piece we need to set in here is a Boolean value. Are we falling or not? Because if we're falling, we need to move down. If we're not falling, we need to move up, right? Okay. Let's see. What else are we going to need to do here? Oh, right. We're going to set up an update function. We're going to say self.frame count plus equals 1. And then here, we're going to switch over to the constants file real quick. And we're going to add in a new constant. Okay. Actually, we're going to add in 2. We're going to add in our plane force, and you'll see what this is in just a moment. And then our plane frame rate. I'm going to set this to 5. I arbitrarily picked 5 because I felt like that worked well when I was experimenting with this before, but you can change these numbers in here and see how it affects things. That's completely up to you. So, what we're going to do here is set up if self.frame count is greater than constants.plane frame rate. We're going to set self.frame plus equals 1, self dot frame count equals 0. Okay? So what this does is, if we've counted enough frames, if we've counted enough update cycles, we're going to update the frame of the image that we're loaded. Okay? And then here we're going to run a second if self.frame is greater than or equal to the length of self.frames. What this means is, now we've gone out of bounds of that frame array that we set up above. What we're going to do is set our self.frame equal to 0. Right? So we're going to come back to 0. We're going to cycle through all 3 frames just over and over and over again. Okay? And then we're going to say self.image equals self.frames, self.frame. Okay. So we're going to grab the current frame from these images. And then we're going to say self.mask equals pygame.mask, exactly what we did above, from surface, and we're going to pass in the image. The reason we do this is because we're updating the image all of these update cycles, and we want to make sure the mask stays matching the current image. Otherwise, you'll get some weird artifacts, especially when you're dealing with different sizes of sprites. Larger sprites, for instance, that have attack animations or things like that. You can end up with collision boxes that look very strange. Okay. The next thing we're going to do is we're going to check, are we falling? If we're falling, we're going to say self.yPosition plus equals constants dot plane force. So that's that force that we set up before. We're going to move down the screen at that force. Okay. And you can experiment with that number. I set it to 1 because it makes it not too fast, not too slow. You can go slower than that. You can go faster than that. Whatever you want to do. You can do move down 1 every 2 frames or whatever makes sense to you. And otherwise, if we're not falling, we're rising. So we want to move up the screen by the same number. Okay? Does that make sense? I hope so. Pretty straightforward stuff. Final piece that we need to do here is update our center. And we're going to do this by saying 75 self.yPosition. Now, I lied. That's not the final thing we need to do. We also need to, every frame that we update, we need to reset falling to true. The reason we're going to do this is because we're going to base this off of, are we holding the key down? If we're holding the key down, we don't want to. We're going to reset falling to false every frame that we're still holding the key before we ever get into this update function. We want to turn it off to make sure it's always turned off if the key is ever released. Okay. And then the other thing we can do here, we can set up another function. We're going to apply upward force here. And this is what we're going to actually call from inside of our event handler. And all we're going to do is set self.falling is going to equal to false. So this is whenever we press the key, we're going to call this function. We're going to set this to false. That way we move up. Okay? So that's the plane. Let's go ahead and go back to our initialization function. Let's get this guy added in. We're going to add it in a couple places. One, inside of the keys here, we're going to say, if the key is being pressed, we're going to say self.player. Oh, we haven't defined player yet, so let's do that first before we do all this. Let's set up our player. Look at me getting ahead of myself. All right, so we've set up the floor. Up here in the initialization, we're going to say self.player is equal to the new plane that we created. And up here, we're going to say from Pygame.plane import plane. So we're going to set up our player. We're going to create it. We're going to call it plane, and then we're going to say self.allsprites.add, and we're going to say self.player. So we're going to add the player to our sprite list so that it gets drawn and updated on every update loop as we expect it to. And then inside of our keys, we're going to call self.player.applyUp if we're pressing the space key. And I believe that's all we need to do for the player. The only way to know for sure is to come up here and hit play. Let's see what happens. Oh, look. Oh, look. Oh, look. We go up and down. If I hold the space key, you can't see me holding it, but you can see it goes up when I press it, and we fall when it doesn't. It seems pretty slow, but it's fine. And then we hit the ground. Oh, and nothing happens. When we're down on the ground, nothing is happening. Okay, well, let's fix collisions here. Let's make these work. And so how are we going to make these work? Pretty straightforward, actually. What we're going to do is we're going to come down here to this update function, and we're going to say, after we update the clock cycle, we're going to say if self.floor.player did collide, and we're going to pass in the player. Now, what can we do here? We're going to want to set a game over state. But for now, let's just print out I'm hit. Make sure this works. Let's print it out and make sure everything works as we expect it to. All right, we're going to fall, we're going to fall, we're going to fall. Oh, I'm hit. I'm hit. Okay. Well, we can see that works. That's exactly what we want to have happen. So let's set up a game over state, shall we? Now, when you build bigger and bigger games, you're going to want more and more complicated state management. For now, all we're going to do is we're going to set up a single state. It's either the game, or two states. The game is either being played or it's over. Okay, and the way we can represent that is with a Boolean. So we're going to, up here in our init function of the game, we're going to set up self.gameOver, and we're going to equal this to false. And then we're going to also load in a game over text. And we're going to say pygame.image.load assets text game over.png. And we're going to convert alpha. Okay. So we're going to create a game over Boolean, and we're going to create the text here. Okay. And then inside of our update function, what shall we do? If the game is over, let's do the simplest thing we can do. If self.gameOver, don't do anything. We're going to pass. Otherwise, do all of this other stuff. Okay. And if we hit something, we want to, instead of printing, set self.gameOver to true. Okay, so what we're doing here is we're saying we're not going to update the game anymore. Let's just see what this looks like. And so you can see when we hit the ground, bam, we're done. Game's over. It's ended. We still want to display the text here whenever this happens. The way we're going to do that is inside the draw function. We're going to say if self.gameOver. We're going to call self.screen.blit. And we're going to pass in the game over text. Okay, and let's put it at like 200, 200. Just see what that looks like. And then there's one more thing. Oh, yes. Pygame.display.flip. Okay, now the reason for that. I'll go ahead and type out the else block here. Otherwise, we're going to update all the sprites and draw them on the screen as they're supposed to be drawn. So this flip here, what this is going to do is this is going to actually apply and bring our new blitted game over text to the front of the screen so that it draws over the top of everything else that's there. Okay. Otherwise, it would never show up. It'd be drawn in the buffer and then never actually display. Okay. Because we're not drawing the entire screen every single frame by doing it this way, we have to call the flip manually to bring that game over text up to the front. So let's go ahead and play this and see what happens. We're going to fall, we're going to fall, we're going to fall. Boom, game over. Okay. So what happens if I hit spacebar? Oh, nothing. We're paused. We're stuck. We're here forever. Okay, so what we can do then is we can reset the game if we hit the space button. So inside of our event handler, we can say if self.game_over, we're going to reset. Let's reset everything. Self.reset. Okay, so we'll create a function here in a second. Else, we're going to say go up. So what are we going to do for reset? There's a couple of things we should do here. So let's create a new function. Def reset. Okay, now we have that function. What are we going to call it? Self.player.reset and self.game_over equals false. Okay, so the player needs to reset. Let's go back to the plane and set up a reset function inside of here. What does this need to do when we want to reset? Well, we need to take it back to the center of the screen. Right? That's pretty much all we have to do. So def reset. And we're going to say self.y_position is going to equal to constants.screen height divided by 2. And self.rect.center. And we're going to put everything back where it belongs. 75 and self.y position. Okay, that's it. So if we run this now, we're going to fall, we're going to fall, we're going to fall. Game over. Let's hit space. Oh, we're back in the middle. Okay, look at this. It's starting to look like a real game. There's a couple of things we're still missing here. So you can see we're doing what we're supposed to do. We're colliding with the ground and we're ending the game. But this game would be super boring if all we had to do was keep up in the air and never hit the ground. So let's add some obstacles. That's the last piece of this to make everything work like a real game. Okay? So we've already got 2 assets here that we're going to use. These spiky grass thingy, rock mountain things. And we're going to go ahead and create inside of here. We're going to create a new Python file inside of our game module, and we're going to call this pillars. Pillars.py. Okay. So our pillars are going to be very similar to the way that our ground works. Okay. So let's make big. Okay. So we're going to import Pygame, import random, and from game.constants, we're going to import the constants object. Okay. Now we need 3 classes or 4 classes. 4 classes inside of here. You'll see how they work in a second here. We're going to start with class pillars. Exactly like the ground, this is going to be our overarching game object that manages all of the pillars for us. Let's go ahead and pass that. Then we need our pillar class itself, and a generic pillar is going to be based off of a pygame.sprite. Okay? And we can pass inside of here as well. Now, we're going to create 2 more classes here. The reason is pillars are either up or down pillars. All right? They're either facing up, they're facing down. It doesn't matter. All we know is that we have 2 pillars up and down, and they are slightly different, but they're going to have a lot of the same update and behavior of the core pillar. So let's go ahead and create an up pillar, and we're going to inherit from pillar. So it's going to still be a sprite, but it's going to have some slightly different properties inside of it. And then we can do the same thing with the down pillar. Okay? And we pass. Now let's start filling in some details here. Okay. Our pillar itself, we'll get to the main game object at the top here in a moment, but let's go ahead and create our sprites and what they actually look like. So we have our pillar base class. This is going to have an init. We're going to call super.underInit. Make sure that we set up our sprite. And then we need three things inside here. We need a delta. This is going to be how it moves. It's going to be the same delta as exists on the floor, which means it's probably a good idea to move this into constants, which we could do later. We definitely should go back and do that. Self.x position, and we're going to set this to constants dot screen width, and we're going to set it off the screen 50 pixels. Okay, so we're going to put this at the far right 50 pixels past the edge of the screen when we create it. Okay, waving hands, and I hit the microphone. Sorry about that. All right, self.y position, and we're going to set this to 0. Okay, by default they're going to have a y position of 0. When we get to up and down, that will actually change. Okay, then we're going to call our update, and every pillar is going to update basically the exact same way. We're going to set self.x position minus equals self.delta. They're going to move across the screen at the same speed as the ground. All right, and then we're going to say if self.x position is less than -50, then we're going to kill it. All right, this is where things start to get a little interesting. Okay, if our x position has moved off the screen 50 pixels on the left, so it's going to move from the right to the left across. Once it gets off the screen, we're going to kill it. What this does is this removes it from all sprite groups. It no longer gets updated and it no longer gets drawn. It is now gone from memory and cleaned up. Okay, so we're gonna cycle through a whole bunch of these game sprites as we add them to the screen and get rid of them. And then after this if block, we'll call self.rect.center, and we'll set that to self.xpos and self.ypos. Okay, so we'll recenter, we'll redraw everything after everything is updated, as long as it's not dead. Okay. All right, so what are we going to do for our up pillar? I'm glad you asked. Let's get rid of these squiggly lines. I hate squiggly lines. They make me upset. All right, define our init, and then we're going to call our super with underInit, and then we'll set self.y position. This is where we actually start to deviate. Constants.screen height. Okay, and magic numbers here again, just like at the beginning. We're gonna set this from the top 110 pixels from the top, and then we're gonna add the offset that gets passed in here. And so inside of our init, we're going to actually pass in an offset of 0 with a default value. Okay, so we're gonna, when we create these up and down pillars, they're going to have offsets, and the offsets will determine how far up and down. What this will allow us to do is to slide the pillars on a random scale up and down a few pixels, so that it adds a little bit of challenge to the game. Okay, now we picked 110 pixels because, as I said, these are a little bit based off of magic numbers, just playing around with it. And so when you have the pillars come up and down, you can see how big they are. Like, they're 108 pixels wide by 239 pixels tall. So we're not quite sliding it all the way down onto the screen. That's not a 110 is definitely not half of 240. Okay, but it's close enough that we're going to have a little bit of overhang on either side. All right, this will also create a slightly wider gap when we create both a pair of up and down pillars, since it's going to be like Flappy Bird where we have a top and bottom pillar at all times. Okay. Then what we're going to do is we're going to load in our image. Okay, so we've set our Y position. We're going to load our image now, and we're going to do exactly what we've done every single time here. image load, and we're going to load it from the assets directory. And I'm using the rockgrass.png, and then we're going to convert alpha. Okay. We're going to call self.mask, and we're going to set that based off of the surface that we just created. All right. And two more steps in here. We need to set our self.rect. We're going to set that to self.image.getRect. So we're going to make sure we're setting the rectangle of the actual object to the image that we loaded in, and then move everything. Self.mypos. Okay. Now you'll notice we don't actually touch the X position inside of this. That's all being done in the base class. So all we're doing is grabbing wherever we have that and copying it over here. Okay. And everything down below, I'm just going to copy almost everything here, word for word. Okay. There's probably some nice abstractions that we can do here since we have some duplicates. But for now, what we're going to do is we're going to, inside the Y position, we're going to change this to only be the offset. Okay. And then inside of this asset, we're going to add rockgrass_down.png. And then everything else stays the same. All of this down here stays the same. Okay. That's the only two changes we really need in here. We need to change where the Y position is and what image gets loaded. Everything else is the same. So let's now define our pillars. Okay. This is going to be a little bit more complicated than the other classes we've defined now, which is why we left it to last. So hopefully you're still with us. Okay, so we're going to create our init, and we're going to create an internal sprite group representation of a sprite group that's going to get passed in. Okay. So just like with our ground, we're going to pass in the sprite group. The difference is now we actually need to reference it later on. Okay. We're also going to set up a pillar sprite group. This is so we can determine if there has been a collision with any of the pillars. Okay. So we're going to set up our own sprite group. Then we're going to call a function that I haven't defined yet, self.spawn. We're going to create our first pair of pillars, and similar to what we did with the animations, we're going to set up a spawn count. And what this is going to mean is that we're going to wait a certain number of update cycles before we add in a new set of pillars. So self.spawn is unresolved, but we will define that in just a moment. So we already created a reset function for the player, so we know that we're going to need a reset function here as well. We're going to have to reset everything on the screen whenever we get a game over. So we might as well reset it here, and this is where things get fun. So we're going to say for each pillar in self.pillar sprites. So for each pillar in the sprites, we're going to just call pillar.kill. We're going to get rid of them. We're going to reset everything, self.spawnCount. It's going to reset back to 0, and then we're going to spawn our first pair of pillars again. Okay? So let's actually define that function. Def spawn. Okay? So what do we need to do to spawn pillars? Well, first thing we're going to do is we're going to create an offset. And that offset is going to be a random dot randint. Okay. Oops. Arrow keys. Randint. And we're going to say, let's go 0 to 100. Okay, we're going to go up to 100 pixels, and we're going to shift up and down based off of that. Okay. And so I've already imported random at the top here. So you can see we're going to be using it here. We're going to create a random integer between 0 and 100. And then we're going to set two pillars. Top equals an up pillar. And we're going to offset it by the same offset as the bottom pillar, which is going to be our downward pillar. And they're going to have the exact same offset. So we want this to be the same so that they have the same gap between them no matter how high they are on the actual screen. And then we're going to say self.pillar sprites, and we're going to add both the top and the bottom. And then we're going to do the same thing. Oops. Adding some extra characters in there. Self.spriteGroup.add. So this is why we needed the reference to the top level sprite group, because we're going to be adding these pillars in to that top level sprite group for it. Okay, so we add it to both. Let's go ahead and create an update function. That's all we need for the spawns. So that'll add that'll add new pillars in. We'll need to update, and the update is going to be pretty simple. So we're going to check our spawn count. We're going to set it one higher. And then we're going to say if it's equal to, or it's greater than, constants dot, let's call this pillar spawn rate. Okay, so we're going to have to go create this new pillar spawn rate inside of constants. But if it is, we're going to spawn a new spawn, and self.spawn count equals 0. There we go. Okay, so if we're higher than this magic number here, we're going to go up to our constants file and set this, and let's set it to 300 frames. This will give us a nice gap between each set of pillars as it moves across. Okay, so here we go. 300 update cycles. Every 300 update cycles, we'll add a new pair of pillars in. Okay? And the last piece we need to make this an actual playable game is another function called player.did collide. And we're going to pass in player. Then we're going to check exactly the same thing we did with the floor. Sprite.spriteCollide, and we'll say player as the main sprite, self.pillar sprites. Any of the pillars exactly the same. We're not going to auto kill, but we are going to set up collided equals pygame.sprite.collide mask without the parentheses. Then we're going to come down here and return true. Otherwise, return false. Okay. So we could probably just return this statement here instead. I mean, I just realized that's probably a simplification we can do and make things a little bit cleaner, but yeah. We're not going to spend, we're already well over an hour here into this one, so let's make this work before we go and update anything. Okay, what do we need to do next? We probably have a few things left to do. Yeah, we're going to have to set up our pillars, right? Obviously. We just created them. We might as well set them up. So self.pillars equals pillars self.all sprites. Okay, so we're going to pass in our reference to our sprite group. We need to import this thing still, don't we? From game.pillars. Oops, not plain. I already have plain. Pillars, import pillars, the main pillars. Okay, there we go. So we're going to set this thing up inside of our init. We're going to create it. We're going to pass in all sprites. It'll add itself to the sprite group for us. That means it'll automatically get drawn. Everything will look peachy. It'll be great. The other thing we need to do is inside of here, we need to say self.pillars.reset. So we're going to reset the pillars after this happens. Okay. The other thing we're going to have to do is manually call because of the way this is all set up, we're going to have to manually call the update on the pillars so that everything moves properly. So we're going to say self.pillars.update. There we go. What this will do is this will actually call this top level update up here, which sets the spawn count, spawns new pillars in. Otherwise that wouldn't get called, and we'd never have new pillars. So there we go. So we're calling that in there. I think this is all we need. Let's run it and see what we get. Hey, look at this. We've got some pillars. Oh, and they're shifting up and down. Everything looks good. Okay. Let's see what happens if we collide with one. Oh, it didn't collide. Oh, you know why it didn't collide? Because we didn't tell it to collide. Okay. Right here. This is it. This is the last piece. Inside of the underinit.py of the game, if self.floor.player did collide, we also need to say or self.pillars.player did collide and pass in self.player. That's it. Let's run it. Let's see what happens if I hit them. Okay. Let's see. If I come up here and I hit it, oh, game over. Okay, so we can fly around. We could probably start these a little bit closer. We don't have to start them all the way up the screen, but at this point, I think we're looking pretty good. Okay. So that's it. We have now just created basically a clone of Flappy Bird. There's some things that you can do if you want to improve this, make it a little bit more playable, make it a little bit easier. I would change the frame rate system so that it's not based off of the number of times the update was called, but is based off of the number of milliseconds that have passed since the last time the update has been called. That would make it a little more consistent. I don't know if you noticed, but it got a little laggy at points. That's because my CPU got busy while we were actually running this video. It's hard to record video and build these games at the same time. So to fix that, you can measure the actual real time that's passed since the last time update has been called. And that's actually the way that a real game would do it. Another improvement you can add is a score system. So every time you make it through the pillars, give yourself a score. You can see when a pillar has crossed the point of the player. If you're not game over and the pillar has crossed right before it kills at a point, there you go. Now you've got a basic score tracking system. You can probably add some additional text here that says press spacebar to start, things like that. There's a lot of improvements you can now take and run with and do. You can I gave you this entire sprites sheet here that you can go in. You can add different types of ground objects. You can add different planes. You can add all kinds of fun stuff in here. You can add collectibles with the stars, or there's just so much you can do here that it will allow you to build on this, experiment, and gain your additional skills with. So I'll leave that as an exercise for you for now, but thank you all for watching. I really look forward to seeing you in the next tutorial videos, where we'll dive even deeper into some more complicated game concepts and build progressively more and more difficult games. All right? Thank you all for watching. I'll see you next time.